The funny thing about big data is that most of us think we understand what it means, but asked to explain it and it gets complicated. So a group of experts got together to try to make a sense of it for the ordinary Joe, and their efforts go on show in an exhibition kicking off this Friday. And some of what you'll see when you get there are, check these out, these vivid images, which, believe it or not, are images rendered from big data gathered by scientists studying the white matter in the brain. And to tell us more about the exhibition titled Visual SG, taking place at the Singapore Science Festival, we're joined by Oliver Sen, Chief Software Architect for Future Urban Mobility with the Singapore MIT Alliance for Research and Technology. Whew, that is a long title. And Professor Alfred Huan, Co-Chairman of the Singapore Science Festival and Executive Director of the Institute of High Performance Computing at A*STAR. Already big data in those titles. Good morning, gentlemen. Thanks for being here. So let's start off with the actual idea behind the festival. You're billing it as visualization that explores the role of data. Now, what do you mean by that?
So first of all, Visual SG is part of the Singapore Science Festival, which is a partnership between A*STAR and the Singapore Science Centre. And the festival kicked off last weekend at Marina Square with the event called Experiment. And there'll be a few other events as well, including this Saturday, where at the Science Centre, visitors can get a chance to try out a self-driving car.
Okay, so it's kind of scary.
Well, how is that big data, though?
Right.
So all these numbers and the data that's collected, I guess just how's that connected?
So a self-driving car would need lots of sensors, and that sensors will be converted into data, and there has to be a computer to compute it all and tell the car where to go, how to go, and not to hit anybody else, how fast to go, where the traffic lies. So that's all big data.
So how is it being interpreted then for this visualization? We saw these images that popped up on the screen just now. How does big data, you're talking numbers, I'm assuming, and huge amount, where's the data coming from? What data is it? And how does it then become this sort of artwork?
Right. I think first of all, we have to realize there's data everywhere. There's data around us in this room. For instance, the time of day, distances between objects, the temperature of the room, circulation of air, humidity, etc. So there's lots of data going around us. Even this show itself, the way that it's getting to the audience is through transmission of data, visual images, audio signals, and so on. And if we put enough sensors around, we can gather all this data and make sense of it. And through that, you can actually improve human lives and condition of life.
Well, Oliver, tell us about some of the projects you're working on with the exhibition.
Yeah, absolutely. I mean, data's all around us, and I think what was kind of like a great discovery was that we had IT systems for 20 years and the internet as well. And but somewhere along the way, people realized that the data that companies and government agencies collect could actually really be used to, let's say, improve the efficiency in cities. So, for example, every time I board a bus and I use my RFID card to pay, there's a record somewhere that stores from where to where, or which other place I'm traveling, right? And only recently people actually started looking at those huge data sets and finding that this gives you a really detailed look of how a transportation system works. And this is incredibly useful for planners to actually then really improve the efficiency. And I think that's why everybody's so excited about this big data, because it really is like a treasure chest to improve efficiencies in cities.
But you're actually also making art out of it.
Absolutely.
So how do you do that?
Where did that concept come from exactly?
Yeah, I think it fundamentally comes from the challenge of working with big data, because so the data is huge, as big data indicates, but also it's very complex because it comes from IT systems. So oftentimes, for example, when we work with telcos, we get just a raw data sample from an IT system that has been out for 30 years. So even at the telcos, they don't really understand it anymore. So it's so hard to understand it, and working with it is so hard that it's so complex, this data, that we can't even come up with the hypothesis anymore to actually formulate questions to then answer with the data. So our approach is really to visualize the data, to really try to come up with visualizations that reveal the patterns in the data. And that's somehow, we do that in collaboration with artists, with architects, with designers, and I think that's where the art in the end comes in. And I think also, it comes also naturally because in those data sets, I think, as with all science, there is really intrinsic beauty. And I think bringing that out is kind of really our motivation as well.
Well, we were looking at pictures just now of, I guess, scales of maps and buildings. Can you explain a little bit about that?
Yeah, so what is also a fact is that a lot of data, at least that we work with, is geospatial. That means it describes events that happen at a certain point in time and are located somewhere. So what happened in research was that with those big data sets, there was a re-emergence of research in infographics and data visualization, mainly because, yes, you have to put that data on a map. It's all location-based data. And so, a large part of our work was really working with maps, basically.
Professor Wang, my ears perked up when you talked about the self-driving car. I'm sure a lot of people are interested in that. But what else can visitors expect when they go to the visual exhibition then?
So at the Visual XG, there will be exhibits like Cities at Night, which basically are night views of cities taken by a satellite orbiting around the Earth at about 830 kilometers. So at that kind of height, viewing Malaysia would be about this size. And what you can then see in that kind of map is the signature footprints that are left behind by human beings on Earth itself. And you can compare different cities, the intensity of the light, and so on. And there's also the Human Connectome project, which basically maps out all the nervous connections in the human body. And
does each color
it shows
represent something different?
I'm not too sure. Maybe it's just artistic. But basically what it tells you are the nervous pathways, the pathways through which nervous signals are being transmitted. But with that, you can actually then understand what makes humans unique, and perhaps humans that are different from humans as well.
What about this animal's X-ray art? What's that? Is that the one that we're looking at?
The animal X-ray art, I think, is just an attempt to bring out the data that's hidden inside the X-ray into an art. Yes.
But you use data to create this.
Well, the data comes from the X-rays in terms of the shade and the contrast. And if you get it right, then you get the pictures portrayed in an artistic manner.
And then the human heart called CardioWorks. Tell us about that.
CardioWorks is interesting. It's actually a work that's done at RHBC, where I am. So a bunch of my colleagues actually came together. One of them volunteered his heart for an MRI scan one day and took it over a heartbeat. And when he put that all together, he got a 3D plus a time image of it all. And then you can see the insides of his heart. And it is an attempt to create a software tool to help doctors perform better diagnosis. And further than that, you can use image analysis to look at the shape of the heart, and then deformities and all that would come out quite naturally. And it could actually better inform the doctors before they decide to operate.
And certainly a much more interesting interpretation than the traditional picture of a human heart, I would say.
Yes,
you know what, Patrick? It wasn't just us, regular people, that are confused with big data. He was saying scientists were also grappling with the complicated issues. So I prevail. Thank you.
You could be grappling with that heart.
With that heart,
as well.
yes. But it looks nice. I can appreciate it. Anyway, thank you so much, gentlemen, for being here today. We were talking about big data and its interpretation into forms that the layman person can understand. Our guest, Oliver Sen, Chief Software Architect for Future Urban Mobility with the Singapore MIT Alliance for Research and Technology, and Professor Alfred Huan, co-chairman of the Singapore Science Festival and executive director of the Institute of High Performance Computing at A-Star. Yay, thank you. Visual SG, which is part of the Singapore Science Festival, as we said, kicks off on July 25th at the Science Center in Singapore. It's on till the 27th of July, and you can visit the website sciencefest.sg for more information. All right, well, that wraps it up for us, guys, on this Wednesday, 23rd of July. Join us again for tomorrow for your regular dose of world and business news.
Plus, our film critic Genevieve Lowe joins us with her take on two movies, Hercules and Hate Ship, Love Ship. Does she love him or hate him? Find that on Box Office. I haven't seen Genevieve in a while, so looking forward to that.
Yeah, should be good. Also on Health Matters, we discuss eye care, contact lenses, and the dangers of not wearing them the right way. We'll get some experts from an eye specialist. Till then, have a great day ahead. Bye for now.